So now I'm going to talk about the Poisson distribution, and if you can't say that, don't worry about it because I have a lot of trouble saying it. So, the Poisson probability distribution is used when computing the probability of a certain number of successes within a specified interval, usually a specified time frame. An experiment follows the Poisson process if the probability of two successes in a small enough interval is 0%, basically it's impossible for there to be two successes in a small enough interval, if the probability of a success is the same for any two intervals which share the same length, and if successes are independent of successes in other intervals. So let me try to give you an example of something that might follow the Poisson process. So at a theme park, there is a roller coaster that sends an average of 3 cars through its circuit every minute between 6 p.m. and 7 p.m. A random variable x represents the number of roller coaster cars to pass through the circuit between 6 p.m. and 6:10 p.m. So first of all, is this a Poisson random variable? Is the probability of two successes in a small enough interval 0%? Yes. In a small enough interval, like say 1 second, it would be impossible for two cars to travel through the circuit at the same time. Are the probabilities of success equal for any two intervals of equal length? Yes, between any two equal intervals, like say between 6 and 6:15 and 6:30 and 6:45, the average, or the probability of success, still remains at 3 cars per minute. And are the successes independent of successes in other intervals? Yes, a success in one interval is independent of a success in any other interval. Like for example, if you get 3 cars in one interval, that won't change the probability of getting 3 cars in another interval. So back to this example, I want to know what is the probability that 35 cars will pass through the circuit between 6 p.m. and 6:10 p.m. So we have this equation right here to find the answer. Now in this equation, x refers to the number of successes. In this case, I want there to be 35 successes. I want 35 cars to pass through. T is the length of time. In this case, we're talking about 10 minutes, the time between 6 p.m. and 6:10 p.m. Now lambda is the average number of successes in an interval of t equals 1. So in a 1 second interval, the average number of successes is 3, because we expect 3 cars to pass through every minute. Now the E in this equation is a constant that you'll find on your calculator. It's a little more advanced than I want to talk about right now, but understand that if you see an E in an equation, it means use something that's close to 2.718. So what I've done here is I've just taken the x, t, lambda, and e and put them into the equation. And now I'm going to simplify and further simplify all the way down until I get the answer. And we find out that the probability that 35 cars will pass between 6 p.m. and 6:10 p.m. is about, well, it looks like about 5%. And that is a Poisson distribution / Poisson process in which we can calculate the number of successes within a certain interval.